Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on November 19, 2025, just 2 days ago. It shows that the very first frame of a video model can act as a conceptual memory buffer, letting the model store and reuse multiple visual entities so it can do robust multi-reference video customization with only about 20 to 50 training examples and no heavy fine-tuning. The paper is titled, "First Frame is the Place to Go for Video Content Customization." And as we will see later, this simple shift in perspective unlocks surprisingly powerful and flexible control over generated videos. Also, the author shared an official GitHub repo for FFGo. There you'll find the full Python codebase, environment and setup scripts, sample test data, and LoRA adapters, plus handy shell scripts for downloading the base i2V model and running single demo or batch video generation exactly like in the paper. Figure 1 demonstrates how FFGo turns the very first frame into a blueprint that drives the entire video. The leftmost image in each row shows a composite first frame, which already contains all the key objects the user cares about. The following frames in that row then show these objects moving, interacting, and staying visually consistent, whether in robot control, driving scenes, product showcases, or film-style shots. This illustrates that a single mixed first frame plus a short text prompt is enough to guide rich, coherent video customization. So while Figure 1 highlighted what the method can do, Figure 2 explains that standard video generators already have a hidden talent for mixing subjects from a composite first frame. The figure compares red boxes driven only by a text prompt with blue boxes that also include a transition phrase, a short description of how the camera should move. With that extra phrase, all three models suddenly align the cars into one coherent racing scene. However, the results show that this behavior is fragile because small wording changes make transitions unstable and objects sometimes vanish or change identity. Figure 3 lays out how FFGo turns raw videos into a training signal and then into customized outputs. The top row shows dataset curation, where unified Vision-Language Models and the SAM2 segmenter identify elements like the person, cake, and hat, and extract clean cutouts plus backgrounds. The bottom row illustrates training and inference, where the mixed first frame and a transition-style caption adapt a pre-trained image to video model through lightweight LoRA updates to produce the final customized video. So while Figure 3 laid out the pipeline, Table 1 reports user study ratings comparing FFGo to 3 WAN-based video customization models. Users scored our method highest in overall quality, with a rating of about 4.3 out of 5. Object identity and scene identity are also strongest for this method, both close to 4.6, which indicates very faithful appearance and background preservation. The average rank is roughly 1.2, which means it is usually chosen over competitors. Most strikingly, about 81% of all comparisons rank this approach first, showing that human viewers clearly prefer the customized videos it generates. Table 1 showed that users numerically preferred this approach, and Figure 5 now illustrates why. The left column presents the text prompt and 3 separate reference images, one for the juice bottle, one for the teddy bear, and one for the roses. The right side compares 4 generated videos, 1 row per method, so we can judge identity preservation and motion. The top 3 baselines either distort objects or lose some of them, whereas the bottom row keeps all 3 subjects recognizable and well composed while they interact naturally. Wrapping up, 2 takeaways stand out. The first frame is not just a starting snapshot, but a powerful memory buffer for storing and mixing multiple subjects, and lightweight FFGo LoRA tuning unlocks state-of-the-art multi-reference video customization from only a handful of clips. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.